Greetings. So today we were just doing a revision of grade 12 functions. Let's first try to understand the statement before we can try to unpack the questions. So they're saying in the diagram, the graphs of f of x, which is equal to x squared plus x, negative x squared plus x plus 2, and g of x, which is half x squared minus x, are drawn below, as we can see g and f. And they intersect at c and d. That is a very important point, intersection. So what we know about intersection is that when the graph intersect, they are equal at the point of intersection. The graphs are equal at the point of intersection. So that means G and F are equal at point D and point C. Before we can even look at what the question is saying, they're saying A is the y-intercept. If A is the y-intercept, then that means the coordinates of A are 0 for x, and okay, where is A found? A is found on the graph of f. So there is the graph of f. We know that C in a parabolic function is the y-intercept, or is the y-coordinate of the y-intercept. So we know A is 0 and 2 before we can even look at the question. Then let's continue analyzing further. P and Q are any points on F and G respectively. P and Q, okay, fine, there's nothing so important about that. PQ is parallel to the y-axis. This is a very important point again. What do we know, or what do we understand about when a line is parallel to the y-axis? If a specific line is parallel to the y-axis, that means x in that line is a constant. We have to understand that. If a certain line is parallel to the y-axis, that means x is a constant in that line. And if a line is parallel to the x-axis, now if a line is parallel to the x-axis, then y is a constant in that line. You have to note that, like, it will help you. When I say y is a constant, that means y doesn't change throughout that line, and the equation of that line will be given by y is equal to a constant. And if it's parallel to the y-axis, its equation will be given by x is equal to a constant. Okay, now let's go to the questions. First question, write down the coordinates of A. We've already written the coordinates of A. It's 0 for x, 2 for y. Calculate the coordinates of C and D. Luckily, we've analyzed that. C and D, we said it is a point of intersection, and at the point of intersection, the graphs are equal. So if our graphs are equal now, that means we are safe to say, for us to be able to get the coordinates of C and D, we have to equate F and G. That means G of x is equal to F of x. So what's the equation of G of x? G of x is half x squared minus x, which is equal to negative x squared plus x plus 2. Then you will group the like terms. Then you will get not really group you will group the like terms, but you will take like half x squared to the other side, as well as negative x. So you will get negative 3 over 2 x squared plus 2x plus 2 equals to 0. Then you will use your quadratic formula. Then you will find out that x is equal to negative 3 over 2, or x is equal to 2. You already know that, as we are because now we are calculating for the coordinates of C, and D. So you already know that this X value is for C because C is found on the second quadrant. And you know that on the second quadrant, X is negative. And you already know that this 2 is for D. D is has a value of 2 for X. Why? Because D is found between the first and the fourth quadrant, and you know that in those quadrants X is positive, so the positive X value must be for D. And you already know the Y value for D because you see D is lying on the x-axis, and on the x-axis Y is 0, as you know that on the y-axis X is 0. So D is the y-intercept. D is the x-intercept. Apologies. D is the x-intercept. So you know at the x-intercept, Y is 0. So D, the coordinates for D, we don't even need to calculate them. We have x2, then you know automatically Y is 0. Then what we are going to calculate now, it is the corresponding Y value for C. So the corresponding Y value for C, you can use either of the equations, meaning you can use the equation for F or the equation for G. I'll just use the equation for G because I feel like it is simpler, but you will get the same answer regardless of which equation you prefer. So for us to get Y at C, we will substitute by X, which is equal to -3/2. So we are looking for G of -3/2, which will then be equal to half of -3/2 squared minus -3/2. Apologies, my writing is not so clear. Then you will have G. Okay, let me just rub this off. You will have G of -3/2 being equals to, you will press your calculator and you will get 8/9. 8/9. Then you know the coordinates for C now are -3/2 for X and 8/9 for Y. And that makes sense if you see the positioning of C, because C is in the second quadrant. Y is positive and X must be negative. X must be negative, Y is positive. So you get that one right. Okay, moving forward. The next question is determine the values of X for which f of X is less or equal to g of X. This is a very important question. You are looking for the values of X for which f of X is less or equal to g of X. As I said in the past video that g of X, f of X, h of X, in this context you are always referring to y, but then you can't say y for everything, because you can't separate one y from the other y. So we use g of X, f of X, h of X to separate those. So when they saying f of X less or equal to g of X, they are saying give us the values of X for which the y value in the graph of f is less than or equal to the y value of the graph of G. So how do we determine whether a y value is greater or less than the other? You know, y at this point is less than y at that point. So that means when we're answering this question, we are looking for the values of x at which the graph of g is above the graph of f, because once the graph of g is above the graph of f, automatically the y values at g will be greater than the y values at f. And this is what we're looking for. We're looking for where the y values at g are greater than the y values at f, or vice versa. Like, let me put it in this way, the way that they put it, where the y values at f are less than the y values at g. The y values at f are less than the y values at g, or they are equal. So we know where f is equal to g. F is equal to g at c, and f is equal to g at d. So to answer this question now, we have to check, okay, at which other point is f equal to g or f less than g? You know, after c here, when you move to the left, every time the y value at f is always less than the y value at g. The y value at f is always less than the y value at g. You can go till whenever, when you are approaching or you are going to the left hand side, everywhere after point c, the y value at f will always be less than the y value at g. That is what we are looking for. 6.3. So we'll say x must be less than, what is the x value at c? There it is. So x must be less than or equal to, because they also included that, or equal to -3 over 2. And also, if you check after d, f is below, g is above. F is below, g is above, meaning f of x is less than g of x at this point. If you check at this point, so if you check, the y value here is less, the y value here is greater. So meaning after d also, f of x is less or equal to g of x. So what is the x value at g? It is 2. So we'll say and x greater or equal to 2, because they're saying less or equal to 2, meaning even the point of intersection where they are equal, you include it. Then we get our 2 marks. Then we can move to 6.4. So to answer 6.4, they are saying calculate the maximum length of PQ, where PQ is the line between C and D. Okay, so let's just do a simple example. We have this line, it's called CD, and we know that the y value here is 8 and the y value here is 4. The y value here, okay, which is okay, it's still fine. The y value here is 8 and the y value here is 4, and we want to calculate the distance CD. Simple, we will say 8 minus 4, and we will know that the distance between C and D is equal to 4. Simple like that. Same applies here. They want us to calculate the distance of what? Of P and Q. So to calculate the distance between P and Q, we will say, okay, P is found on f of x. So we'll say f of x minus g of x is equal to PQ. I told you that these represent y, so I'm saying y at P minus y at Q will actually give me the distance between P and Q, which is true because x is constant. So I'm not going to include x, because if I include x is going to give me 0 anyway, because x is constant when a line is parallel to the y-axis, as we said before. So what's the equation of f of x again? Let's go check it. The equation of f of x is negative x squared plus x plus 2 minus 1 over 2 x squared minus x is equal to pq. You can move back. So that means pq is equal to negative 3 over 2 x squared plus 2x plus 2. Then to calculate the maximum value, now you know how to calculate the maximum value. You say x is equal to negative b over 2a, so that means it's equal to negative 2 over 2 times negative 3 over 2, which is equal to 2 over 3. Yeah, it's equal to 2 over 3, positive 2 over 3. Then this is the x value, but you can't measure this line by x, but rather by y, as I told you that if we have y equal to 8 here and y equal to 4, we would subtract those y values. So now that we have the x value, then we are looking for the alternative y value, which will be the distance from P to Q, or from Q to P. Then to get PQ now, we will substitute by 2 over 3 in this equation, because we already have the equation. There it is. So we'll say negative 3 over 2 into, what is the value of x? It's 2 over 3 squared plus 2 into 2 over 3 plus 2. Then we know our PQ will be equal to 8 over 3 units. So moving on, we don't have a lot of minutes left. We're moving to 6.5. Question number 6.5. So 6.5 states that we should calculate the value of x where the gradient of f is equal to 3. The gradient of f is equal to 3. What you need to understand here is that the derivative of x is the gradient of f. The derivative of f is the gradient of f. So when they are saying the gradient of f is 3, they are actually saying the derivative of f is 3. So let's but if you haven't done calculus, what I'm saying won't make sense until you do calculus. So if you haven't done calculus, no problem. There is no problem if you don't understand this question. So if we are deriving here, then we will have negative 2x plus 1. The gradient is 3. That means the derivative is 3. Then x is definitely going to be negative 1. Then we are done with that question. Then we're doing the last question, which is question 6.6. Okay, so the last one, as I've said that we don't have much time left, so they're saying 6.6, determine the values of k for which f of x is equal to k. Be very careful around here. Values of k and f of x is equal to k. Remember what I said, f of x, g of x, and h of x. we are all, like every time we mention those, we're talking about y. So when they're saying f of x equal to k, that means k is actually a y value, meaning whatever that we're gonna write the y values when talking about k, because f of x is equal to k, or f of x is k, and you know that f of x, g of x, h of x are representing y. And so here we are looking for when f of x is equal to k has two positive unequal roots. Two positive unequal roots. So a root is just a fancy way of saying an x value. So we're looking for the values in the graph where we have two unequal positive x values. Here, for example, it's a negative root. It's a positive root, meaning it's a negative x value, positive x value, negative x value, positive x value, until point A. After point A, we have 0 for x, then a positive x value. A little, like, I don't know, like above, slightly above A, we have a positive x and a positive x, a positive x and a positive x, up until we reach the turning point. So that means what they are talking about here happens when k is between A as well as the turning point. A as well as the turning point, meaning k must be greater than A but less than the turning point. That's what we are looking for if we want to get two positive unequal roots. So we already know A has a y value of 2. We don't care about the x value. The x value is 0, and we are not looking for the x value because we're looking for k, and k equates to y, which is f of x. So we're looking for the y values. So y at A is equal to 2. But now we're looking for the y turning point. So for us to be able to get the y turning point, we should first get the x turning point. So xTP is equal to negative b over 2a, which is equal to negative, what's the value of b for the graph of f? Let's just go back. B is negative, it's positive 1 actually. So we have this over 2 times negative 1, then we get half. Now we know the x turning point is half, then we need to substitute by the x turning point for us to get the corresponding y value, or to get the y turning point. So we are looking for f at half, which is equal to negative half squared plus half plus 2. Then f at half will be equal to 9 over 4. Then you know our answer now for the last question, which is the points where we get two positive unequal roots for the graph of f. Then you know we know that it's between 2 and 9 over 4. It's between 2 and 9 over 4. Then we're done with the last question. Hopefully we will do more questions in other lessons, but for now I feel like we might just stop right here.